Is the future one built around agentic autonomy, where AI systems don't just suggest code but execute complex actions with minimal human input? Well, that's what we're exploring in this week's video based on the Data Pro News edition from March 19, 2026.
In 2025, software development went through a rapid transition. Instead of manually typing out syntax line by line, engineers began outlining their intent using spoken English, while AI models handled the actual keystrokes. This shift created an immediate surge in productivity. Junior developers could spin up complex applications in days instead of months, and for a short window, the absolute speed of delivery became the only metric that mattered. These tools evolved. They became agents, systems capable of planning and executing multi-step workflows across live infrastructure with minimal human oversight. Relinquishing the keyboard to an autonomous actor shifted the risk profile of software development instantly. The potential cost of an error scaled up to match the agent's speed. We saw exactly how high those stakes were during the Claude Code incident. It started with a routine task. An engineer prompted an AI agent to help migrate a training course management platform over to AWS. Instead of carefully mapping out the migration steps, the agent made a massive leap in logic. It bypassed the deployment process entirely and went straight to executing a removal command meant to tear down infrastructure. In seconds, the system vaporized the platform's production environment. The live database, all the backup snapshots, and 2.5 years of student course submissions were permanently erased. This loss occurred without a malicious hack or an exotic edge case. It was the direct result of machine speed execution meeting unattended authority. To truly understand exactly how this disaster happened, we have to look at what the agent actually saw. Based on the limited information it had access to, the AI was making a completely rational choice. Agents check environments using a Terraform state file, a map of existing servers. Because this file was missing, the agent scanned an empty directory, concluding live servers were errors. It then issued destroy commands, erasing working databases until reality matched the empty folder. The agent was allowed to do this because it held excessive administrative permissions. There was no hard approval gate requiring a human click, and no limit placed on its blast radius to restrict how much it could delete at once. When intent replaces syntax, catching typos is no longer the job. The engineer's primary responsibility becomes designing failsafes against logical misunderstandings. Software engineers can usually just revert a bad code commit and restore a previous version of an app. Data engineers deal with systems that hold state. Once a database is dropped, those decisions are destructive and permanent. And these autonomous tools are now wired into every layer of the data pipeline. Agents control data ingestion, they manage transformations, they configure storage, and dictate downstream analytics. This illustrates the multi-agent problem. A single agent makes a slightly incorrect decision at the top of the pipeline. Because agents are chained together, that tiny error is ingested by the next as ground truth, multiplying as it cascades downward until the system fails. In a highly connected ecosystem, letting AI operate on pure momentum guarantees that a minor local mistake will amplify into a catastrophic loss for the business. By 2026, AI is embedded into the tool in itself, meaning teams cannot simply opt out. Instead, the data environment has to be structurally fortified to survive autonomous behavior. The first rule of this new architecture is downgrading trust by default. Every action proposed by an agent must be treated as an unverified anomaly until a human engineer proves that it is safe and correct. Second, the system requires explicit hard stop approval gates. AI tools should lack the permissions to alter production data or core infrastructure unless a human manually verifies and authorizes the specific command. Finally, the architecture must make failure boring. Destructive actions like deletions need to be artificially slowed down, heavily logged, and paired with a guaranteed rollback path before they are allowed to proceed. Modern data platforms have to be built as high-security containment vessels. The environment itself must dictate that an agent simply cannot delete critical resources, no matter how hard it tries. The early promises of natural language coding didn't eliminate the hard work of software development. They just moved the primary challenge away from writing perfect syntax and heavily toward managing operational risk. The teams succeeding right now aren't the ones writing the cleverest prompts. They are the teams armed with the deepest knowledge of system architecture. When code is generated and executed in a fraction of a second, seasoned human judgment and enforced engineering discipline become the only reliable barriers between an organization and total data loss. Using conversational English to write code was merely the entry point. The real job of a data engineer today is to build the impregnable cage that keeps autonomous AI safe.
Hey, thanks for checking out the Data Pro Explainer video. Don't forget to give us a follow and check out the Data Pro News at datapro.news, which is linked in the description. And then why not head over to our school classroom, which is also linked below, to discuss this and meet other data professionals from around the globe.